Today's lesson is about graphing exponential and logarithm functions. Now let's analyze the exponential function. First of all, for y equals a to the x power. And this a has to be greater than 0. And then it passes through the points 0, 1. If a is greater than 0 and less than 1, look at this function and this, then it will be decreasing. The function is decreasing. If a greater than 1, look at this, then we could see the function is increasing. We have another name for decreasing exponential function, that's decay. And for increasing function, we see the growth, exponential growth. And I can rewrite that 1 over 3, I can write down 3 to the negative first power, so negative x power. And for 1 over 2 to the x power, I can write down 2 to the negative x power. It's the same. For exponential function, there is a horizontal asymptote line. And for y equals a to the x power, definitely that will be y equals 0. That's the horizontal asymptote line. For general form, that's p times a to the x power plus q. We know that a to the x power, that means y greater than 0. I multiply by p, that's still greater than 0 when p is positive. Then I need to add a q, that means y greater than q, that's the range. When p less than 0, then you know that y greater than 0 will be changing to y less than 0, then y less than q. No matter what, the asymptote line will be y equals q. That's the asymptote line. As we know, exponential and a logarithm function, they are inverse function. In other words, the graph will be reflect across y equals x for exponential and a logarithm function. Also from the graph, we could see when a is greater than 0 and less than 1, both logarithm and exponential function are decreasing. When a greater than 1, both exponential and a logarithm, they are increasing. Now let's analyze y equals log base b of x. First of all, b greater than 0 and b not equal to 1. For the exponential function, and also the a cannot be equal to 1. Second, for domain x greater than 0, and the range will be all real numbers. For third, when b greater than 0 and less than 1, logarithm function will be decreasing. And when b greater than 1, then for logarithm function, it's increasing. You could see from the graph that's decreasing, and this one is an increasing function. So for logarithm function, there is a vertical asymptote line. For these three, the vertical asymptote line will be y-axis. Then from the exponential function, we could see the x equal to 0 will be the vertical asymptote line. We go back to this number 1. We use transformation. We will make a parallel function table. That is x, here's y, -1, 0, 1. Your parallel function will be y equals 3 to the x power. Therefore, we got 1 over 3, 1, and 3. For exponential function, domain is all real numbers. For range, I will set up exponential form y greater than 0. 2 positive number times 0 still positive. Then I add 1. You will get the y greater than 1. Your asymptote line will be y equals 1. First of all, we got to draw a parallel function. You get the -1, 1 over 3, 0, 1, and 1, 3. This is 3 point. Then we got to do transformation. For these two, that means vertically stretch by factor of 2. For this plus 4 means move to the left 4 units. Plus 1 means go up 1. Therefore, for each point, I got to do these 3 steps. For 1 over 3, we multiply by 2. That will be 2 over 3. Let's go here. Then move to the left 4 unit. 1, 2, 3, 4. It's here. Then you go up 1. It will be here. That's the final point. Now let's go to this 0, 1. We vertically stretched by a factor of 2. Let's go here. Then move to the left 4. 1, 2, 3, 4. It's here. Go up 1. Then I go here. Now let's move this point. Vertically stretched by factor 2. This is 3 times 2 is 6 here. Go left 4. 1, 2, 3, 4. Then go up 1. It will be here. This point. You need to draw asymptote line y equals 1. That's this asymptote line. Then you need to connect these 3 points. This will be the graph. For number 2, domain, that's all real numbers for exponential function. Range, you will set up exponential form y greater than 0. Then you minus 1. You will get the y greater than -1. Asymptote line will be y equals -1. This will be the asymptote line. Then we get the parent function. This is x, here's y. Negative 1, 0, 1. 1 over 3, 1, then 3. So we get negative 1, 1 over 3. That's here. 0, 1 here. 1, 3. That will be here. Let's talk about transformation. For these two, that means horizontally compressed by factor of 1 over 2. Remember, insider is a liar. Whenever number with x, we call that's insider. Minus 4 means move to the right 4 unit, then go down 1. Therefore, for this 3 point, horizontally compressed by factor 1 over 2, that means your x-axis divided by 2. Therefore, we got over here. This is the 1. Then go to the right 4. 1, 2, 3, 4. It's here. Then go down 1. It will be here. Now let's go to this point. Horizontally compressed by 1/2. Your x coordinate 0 divided by 2 still 0. Then move to the right 4. 1, 2, 3, 4. Go down 1. It will be here. Then we go to last point. This point. Horizontally compressed by 1 over 2. So 1 divided by 2, that will be here. Then go to the right 4. 1, 2, 3, 4. It's here. Go down 1. We got this point here. Then we need to connect these 3 points. This will be the graph. Now let's go to number 3. This time, the parent function is y equals 1 over 3 to the x power. So we got the xy. Still using negative 1, 0, 1. You got 3, 1, 1 over 3. Domain is all real numbers. Range. Whenever you say exponential form, make sure it's greater than 0. Then 0 times 1 over 2, still y greater than 0. Asymptote line will be y equals to 0. You will draw this asymptote line first. Then we draw the parent function. You got negative 1, 3, 0, 1. And a 1 is 1 over 3. It's here. Then we got to do transformation. Only one transformation, that is vertically compressed by factor of 1 over 2. Means your y coordinate divided by 2. Therefore, this point divided by 2, it will be 1 over 6. Let's go here. This point divided by 2, you will get the 1/2. This point, you divided by 2, you will get 1.5. It's here. And I connect these 3 points. This will be the graph. For number 4, this time, still your parent function will be 1 over 3 to the x power. We set up the parent function x, y, -1, 0, 1. You got 3, 1, and a 1 over 3. Domain definitely is all real numbers. For range, you set up exponential form y greater than 0, y greater than 0. Therefore, asymptote line is y equal to 0. So we got -1, that's 3. It's here. 0, 1. Then you get 1 over 3. Let's go here. Now we got to do transformation. 1 over 2, that's a liar. So we do horizontally stretch by factor of 2. Your x coordinate multiplied by 2. This coordinate multiplied by 2 will be 2 here. This point, you multiply by 2, still 0. For this point, you multiply by 2, you get -2. Let's put over here. The asymptote line is y equal to 0. It's this line. Then you need to connect these 3 points. The graph will be like this. Now let's go to number 3. This is a logarithm function. We will set up a domain, your argument greater than 0. So we set up x plus 3 greater than 0 means x greater than -3. So the asymptote line will be x equals -3. Range is y is all real numbers. First of all, we still get the parent function y equals log base 2 of x. Then we get the point. This time we got to use range is -1, 0, 1. So 2 to the negative first power, that's 1 over 2. 2 to the 0 power is 1. 2 to the first power, that's 2. So we got this 3 point. 1/2 -1. It's here. 1, 0. Then 2, 1. We will draw that asymptote line. X equals -3. It's here. Then we got to do transformation. Negative sign. That means reflect across x-axis. For +3 means move to the left 3 units. -2 means go down 2 units. Therefore, for this point, I will reflect across x-axis is here. Then you move to the left 3. 1, 2, 3. Go down 2. 1, 2. Go here. For this point, you reflect across x-axis still here. Then move to the left 3. Go here. Go down 2. 1, 2. Go this point. Then we go to this point. Reflect across x-axis is here. Left 3, 1, 2, 3. Go down to 1, 2. Then we connect these 3 points. Make sure x equals -3 will be the asymptote line. Therefore, the graph will be like this. For number 4, domain, I will set up 1/2 for x greater than 0. Argument greater than 0, therefore x greater than 0. Asymptote line will be x equal to 0. For range, that is y will be all real numbers. We have a parallel function log basis 3 of x. From those 3 points, you have x, y, -1, 0, 1. 3 to the negative first power, 1 over 3. 3 to the 0 power is 1. 3 to the first power, that's 3. We will draw asymptote line. X equals to 0 means y-axis. Then we will find this 3 point. 1 over 3, -1. This point. 1, 0 is here. 3, 1 is here. Then for the transformation, 1 over 2 means horizontally stretched by factor of 2. Plus 2 means go up 2 unit. Horizontally stretched by factor of 2 means the x-axis multiplied by 2. Since you got the 1 over 3 multiplied by 2, that will be 2 over 3. Then go up 2. Go here. Then go up to 1, 2. It's this point. For 1, 0, this point, you horizontally stretch by factor of 2. Let's go here. Your x multiplied by 2. Then you go up to 1, 2. This will be the final point. For this point here, you will get horizontally stretched by factor of 2. You got 1, 2, 3 multiplied by 2 will be 6. From 6, I go up to, you will get this point. Then you need to connect these 3 points now. You will get like this. Make sure do not cross this asymptote line. Now for number 5, domain, I will set up x minus 4 greater than 0. So you get the x greater than 4. Range, that will be all real numbers. Your asymptote line will be x equal to 4. Parallel function, you get the y equals log base of 1 over 2 of x. So for that table, you have x, y. You got the -1, 0, 1. 1/2 to the negative first power, that will be 2. 1/2 to the 0 power is 1. 1/2 to the first power, that will be 1 over 2. Therefore, we draw asymptote line first. X equal to 4. 1, 2, 3, 4 is here. We draw these 3 points, 2, 1, 2, negative 1 is here. 1, 0 is here. And 1 half 1 is here. For the transformation, this one means vertically stretch by factor of 3. Minus 4 means move to the right 4 unit. So for this point, let's get started from this point. Vertically stretch by factor 3. You have 1 times 3, you will get 3 is here. Then go to the right 4. 1, 2, 3, 4. It will be here. For this point, vertically stretch by factor of 3, your y-coordinate multiplied by 3 is still here. Then go to the right for 1, 2, 3, 4. We go here. Let's go to this point. Vertically stretch by factor of 2, you will from negative 1 go to negative 3. It's here. Then go to right for 1, 2, 3, 4. It's here. Then you need to connect these 3 points. You will get like this. Now let's go to number 6. Domain, I will make sure negative x greater than 0. Therefore, x less than 0. Because you divide by negative 1 both sides, you need to switch the symbol. Still, your asymptote line will be x equal to 0. Range is all real numbers. Your parent function, you will get the log base 1 over 3 of x. For that table, you will get the xy, negative 1, 0, 1. 1/3 to the negative first power, you will get 3. This is 1. This part is 1 over 3. We will draw asymptote line first. X equals to 0. 3, negative 1. Go here. 1, 0. Go here. 1/3 1. We go here. That's your parent function. Then we go to do transformation. This one means reflect across the y-axis. Minus 4 means going down 4 units. Therefore, for each point, I go this point, reflect across y-axis. Then go down 4. 1, 2, 3, 4 is here. Then go this point. Reflect across y-axis, go here. Go down for 1, 2, 3, 4. We go here. Now let's go to this point. Reflect across y-axis. You will get here. Then go down for 1, 2, 3, 4. Then connect these 3 points. You will draw the graph like this.